Kubernetes for Humans.
Hello, everyone, and welcome to another episode of the Kubernetes for Humans podcast. Today, we have in the show David. David, can you please introduce yourself?
Sure. Thanks for having me on the show. My name is David Morrison. I'm based out of California, and I'm a founder and research scientist at a small business doing Kubernetes scheduling and autoscaling. And yeah, excited to be here. Thanks for having me.
Kubernetes scheduling is always interesting, but before we jump to what you are currently doing, can you share, please, a bit about your journey? Where did you start? When did you first, when you were first introduced to Kubernetes? And a bit more color on what
Sure.
led you to do what you do.
Sure. So I actually didn't start in distributed systems at all. I was doing I was in the field called operations research, which is kind of the study of like algorithms and logistics and planning and optimization. Um, and I ended up at Yelp, which is review websites or review restaurants and other places. And I ended up on their distributed systems team where they wanted me to save some money on their AWS bill. And that was
And
sort of my sorry.
you didn't had any experience with that, that was your task, reduce the bill
Yep.
without really knowing. Okay, that
Yeah.
sounds like
It was kind of a trial by fire.
yeah, it
But
sounds like that.
when I started at Yelp, we were using Apache Mesos. And so I spent a whole bunch of time sort of learning the ins and outs of Mesos and also just like how distributed schedulers and like cluster orchestrators work. And then my first introduction to Kubernetes was in, I think, 2017 or 2018. We switched at Yelp from Mesos to Kubernetes, like a lot of other companies did at the time. And so was really spending a lot of time like trying to understand like how are they the same and how are they different and like how can I apply some of my skills to this like brand new technology.
Is the migration something that how was it decided, or what was your place in the process? Because back then it was being an early adopter to do this my kind of migration. Most companies, it took them 3, 4, maybe 5 more years. So maybe share a bit
Right.
about, and I guess you guys already had a huge setup, but share a bit about that.
Sure. Yeah, it was a big point of discussion. It was, I think, when we finally migrated, I think we were on like Kubernetes 1.14 or 15, something like that. But it was a big discussion of is Kubernetes going to be the thing that we should use, or should we stay with Mesos? We had quite a few like long conversations with me and my team and engineering leadership about what the right direction there was.
Mhm.
Kind of.
So how did Kubernetes win in the end? Why? How?
Um, we had another person on the team who had, gone to KubeCon a couple of times, had played around with Kubernetes and like small scale experiments, and I think was just, in general, really clued into the industry direction. And his comment was like, "Look, this is where everybody's going," and Kubernetes gives us a lot of capabilities that Mesos doesn't, and so we should make this switch. Um, I was, I think, sort of funny. I was sort of on the opposite side. Like I kind of wanted to stick with Mesos because it was what I knew and I thought it was a really cool piece of tech. But in the end, I'm glad that we made that decision.
I think Mesos is a really cool piece of tech. I'm a huge Kubernetes adopter, but I think Mesos had a lot of things that he've done right.
Mm-hmm.
It wasn't a playground project, but share it to me. How much time did you did it took you guys to migrate? I have one of Commodore customers is a huge Mesos setup, and I think it took them 3 or 4 years to do the migration end to end. How much time did it took you guys, and how painful was it?
So it was not that painful. One of the things that Yelp did really well is they built a API layer. It's actually open source. It's called Pasta. You can go look it up on GitHub if you want to. Um, but it's an API layer between the cluster and the cloud and all of Yelp's developers. And so we were, and like the abstractions that they implement there were like very well done. Um, I was not involved in building that part, so like I really have to commend the authors for that. But what it meant was we were able to swap out from Mesos to Kubernetes without really impacting what Yelp developers did or how they did their jobs. And so I'm not going to say that it was painless, but I think we did the bulk of the migration in like a year and a half or something like that.
Quite impressive. Quite impressive, to the scale and the company and so on. And what happened next for you, for Yelp? Like, okay,
Mhm.
you, you found out about Kubernetes, you ditched Mesos, even you liked it. What now?
Yep. So I spent about 4.5 years at Yelp. I left in late 2020 and moved to Airbnb. And I was doing, more of the same. Airbnb was all in on Kubernetes. And so I spent a bunch of time there doing autoscaling. I'm actually an approver on the Kubernetes cluster autoscaler project, and got some, cool commits in there. But yeah, same sort of work, just a different place.
Okay, and then what? Like,
Yep. And so then after Airbnb, in 2023, I jumped ship and started off on my own. So I have a small business, Applied Computing Research Labs, um, and we're really focused on helping you, do scheduling and auto scaling and save money and increase reliability. Um, One of the cool projects that I've been working on is this thing called SimCube. And what this does is it basically creates a simulated Kubernetes cluster. So you can take, uh, your production workloads, your 2,000 node cluster or whatever. You could record a trace of it, of the last 24 hours of data, and then you can replay that in a simulated environment on your laptop.
well, one second. Like, how does it work? Like walk me through the details. Like, Kubernetes has a lot of like moving pieces, right? Like,
Yeah.
there's the Kubernetes layer itself, there's the scaling, there's the traffic, there's the network. Like, what parts are you guys simulating, and like, what's the main use case for that? Like, is it to
Yeah,
test or
so the main use case is trying to understand the Kubernetes control plane better. So in SimCube, I'm running a real control plane. I have API server, controller manager, scheduler. You can set up an autoscaler if you want, or if you have any other custom controllers. All of that stuff's real. What's fake, what's simulated is the data plane. So all of the nodes and all of the applications that are running on those nodes are mocked out. I'm using this project called Quack. It's Kubernetes without kubelet. And basically what it does is it emulates the kubelet API, but there's no actual real hardware, there's no Docker, there's no code that's running there. And so this is the sort of secret sauce that lets you run 2,000 nodes on your laptop, because there's not actually anything happening on the sort of application side. Um,
and like, who are the users? Like, who is using it? Like, what's like, I understand why it can be helpful for someone like you, but what people who are like not in that domain are using it? Like, what's the main use case? Like, checking different strategics of like scaling, right? But what else?
mhm. Yeah, so I think there's a few different use cases. Trying to understand, you know, something that happened yesterday is sort of one use case of like maybe there was a incident or an outage with your cluster and you like don't understand what went wrong. Then you can replay the events locally and really go in and like debug and troubleshoot. I think another cool use case is what's going to happen tomorrow. So maybe, you're trying to do capacity planning, or your boss comes to you and says, like, we're expecting 10 times traffic tomorrow. Like, what's going to happen to our cluster? Like, where is it going to fall over? You can actually, uh, based on like your production data, you can actually, make some predictions about what that would look like and where your bottlenecks are going to be.
But will it simulate like the network as well, like the different like distribution, like simulating? And like I spend a lot of my time trying, doing like A/B testing for like large system cluster. It's extremely like hard, right? Like you don't know where the traffic will be, what
Right.
users, what there are so many moving pieces. So like, does it captures everything, or does it mainly captures like the big blocks of compute and network?
Right. So, it doesn't, because again, there's no application code running. It's not able to simulate the sort of network and traffic patterns. But what you can do is you can say, oh, this pod or this deployment correlates with our traffic. And so, when we have high traffic periods, it's running 100 replicas. And so we know that if our traffic doubles tomorrow, then we're going to need to run 200 replicas for this deployment. And so it's not perfect. Like you still have to think about a little bit where your traffic's going to go and how that impacts things. But once you've sort of done that, then you can run that run that simulation and see how your cluster behaves.
Okay, no, that sounds interesting. So 1 second, like I feel that we jumped like too much to like the technical aspect.
Sure.
You are in Airbnb, you are in Yelp, like like not big companies, but like large like enterprises, like large like large startup or like small enterprises, no matter how you want to view them. Why to jump ship? Why to open your own company? How was the process? How it's working for you? So share a bit about that. Like I'm sure that a lot of our listeners might have like their own cool idea in the space. So yeah, share a bit about that.
Yeah. This is a thing that I've been thinking about for a long time. Even before I was at Yelp, I was kind of like wondering, I wonder what it'd be like to, just run my own company. And I think uh, it was being at these large companies, or these like enterprise companies, gave me the experience and the sort of network and the ability to take that next step. So I'm really glad that I had that opportunity. But what I love about what I'm working on is, like, I'm not just building something for one company. I get to build things that help people all over the world.
Mhm.
And that, like that's really exciting to me. So, if you have other listeners who are thinking about this, like, it's not easy. It's been a slow, hard road. But I'm really enjoying it. This is the best work I've ever done. So
That's fun to hear. So maybe go into the details. You left, and what's the goal? Like what yeah, like what do you do? Like in the end of the day, why should someone hire you guys? And
sure,
what you provide, and what type of customers do you have?
sure. So right now, the bulk of my work is done in consulting. So people come to me and they'll be like, "Hey, we want to understand why our Kubernetes clusters are so expensive," or we just switched from cluster autoscaler to Carpenter, and we don't understand how to tune Carpenter to be cost effective. So it's these really like sort of targeted questions of how can we save money, how can we improve reliability. um, I think SimCube was originally designed sort of as a tool sort of internally for me to use. What I've discovered is that there are a bunch of other people who are like, wow, this is really cool. We'd love to use this in our environment. And so what I'm trying to do long term is to build more of a business around like helping people come in, simulate their clusters, do real data analysis on what's happening in their environments, and then we can answer questions, the same sort of questions we talked about before of how do we scale or how do we save money, and then take that to your CEO or your CTO, and back that up with, these are real numbers.
Okay, okay, that makes sense. So when you are consulting, what are the patterns that you usually see? Again, let's assume I'm a platform engineer, I have a lot of clusters, I have a lot of developers. What am I doing wrong most of the time? What should I do? And yeah, like maybe share a bit more about, like the dirty stuff of, how does the world actually looks like outside of like Airbnb and Yelp, which I'm sure that they are not represented the industry and the scale, the level, like a lot of things.
Sure. I mean, one of the things I've discovered when I talk to people is, uh, everybody's doing stuff a little bit differently, but by and large, we're all trying to solve the same problems. We want an application that's reliable and that is useful to people, and we want an application that doesn't break the bank. Um, and uh, in a lot of these companies and organizations, your platform team is not your core competency. It's a thing that's there to support the actual business. And that puts a really sort of funny dynamic on how you prioritize and what conversations you have. Um, because it's really difficult to tie a direct line between any particular change that you make to your infrastructure and how that makes your business better.
Mm-hmm.
And so that's really one of the things I want to be able to do is come in and be like, look, if you make this change, this affects your bottom line in this way. That's something that I don't know that I've really been anywhere where they've been able to answer that kind of a question before.
Okay, no, so it's like the business side to the technical side.
Mhm.
Like I saw, I think like a study from, I want to say Cast AI, but maybe I'm wrong here, that most like Kubernetes clusters are only like 10% utilized. Is it
Right.
something that you see as well for your customers? And if so, like why? Like everyone knows that, if I just double like from 10% to 20%, I'm saving half of my cost, right? Like assuming. So why do you think this happens? What should they do? And maybe again, like, yeah, like maybe a bit more details on that.
Sure. I think I 10% seems low, based on what I've seen, but certainly like 30 to 40% utilization is not uncommon.
Mhm.
And I think there's a bunch of reasons for this. It's really hard if you're a platform like or if you're a product developer somewhere, you just want your application to work. And so if it runs out of memory, you're just going to go in and you're going to double the memory. And it's going to work, and then you're going to move on with your life, and you never really come back and think about like what the implications of that are. And so it's tough as a product developer to really understand the impacts that you make. Um, and then also, it's really tough, even as a platform engineer, to understand uh, the choices that the people that you're trying to support are making and how that impacts everything in your cluster. Um, and so even and so I think one of the reasons why you see these low utilization numbers uh, is um, there's not clear observability and visibility into how individual choices impact sort of the whole.
Okay, okay. No, I think like what you're saying makes sense. So no, maybe like like cost saving is something that is very trendy, right? Like everyone is talking about it. Almost all of our customers and most of the prospects that we meet have like a huge initiative. Let's reduce cost by I don't know, like, a lot.
Mhm.
Like most of those projects or a lot of them are failing, right? Like why? Or maybe you again, like maybe you do see something wrong. Even your job is to consult for companies that I guess struggle. So
Mhm.
like yeah, like share a bit more about that maybe.
Yep. Um, I think we're in like a day 2 operations phase with Kubernetes
Mhm.
and like these platforms now. And so most of the low-hanging fruit, like it's really easy to turn on autoscaling and then you're saving $1 million a year. Easy, done. Once you've tackled this low-hanging fruit, um, it's really difficult to understand if I make this specific scheduler change, is that actually going to save us money? And there's so many different control loops and moving pieces in there. So like maybe you make a scheduling change to bin pack your pods more efficiently, but your autoscaler is trying to scale up nodes so that everything gets spread out. And so you end up in this situation where you've got two control loops that are fighting with each other. And so you don't actually end up saving any money. Then you throw in things like for AWS, you have like reserved instances or savings plans where you have committed spend. And maybe you're using fewer resources, but it doesn't actually change your bill at all because you told AWS I'm going to spend X amount for the next 5 years. And so really understanding how all of the technical and sort of social and economic things tie together is like it's really challenging. And so it's not surprising to me that people are struggling in this area.
Like I think we see similar patterns. One thing that I had like a very interesting discussion with like one of my coworkers the other day is on-prem. Like, is it a thing? Are people going back to on-prem? Did they never left on-prem? Like, what's your take when we see the cloud providers are gaining more and more popularity? Maybe share a bit more about that from like a cost perspective or efficiency. So what do you do? What do you see? What do you think?
Yeah, this is a great question. There's certainly a lot of like splashy headlines about how we saved money going back to on-prem. Um, I think there's a few factors going on. When we, like as an industry, when we moved to the cloud, there was this whole job description around capacity planning that we just lost. The cloud is infinite for all practical purposes. And so nobody has to think about their capacity. And so I think a lot of these companies that are sort of going back to on-prem are seeing value from that as a forcing function of now we actually have to think about our capacity again. And so, we can make trade-offs about how many resources our application really needs instead of just treating this as an infinite resource that we're really disconnected from. Um, I think there's also an argument to be made that some of the cloud providers, they exist to make a profit and they want to make money too. Totally fine. Um, but I think there's potentially an argument to be made that uh, they make it a little harder to understand what you're actually spending than uh,
That's
would be
true.
ideal.
No, that I think like no one will say. I don't think you can argue with that, can you?
I
Like,
don't think so.
like I feel that not really. Like in the end of the day. Um. So do you think that like 5-10 years from now we will see more on-prem because it's like maybe like the easy resort, or like where are we going as an industry?
Um, I think what we see as an industry is it's kind of like a pendulum. We see this in all kinds of different fields. We're seeing this in AI right now. There was a long period where people were like, well, AI is meaningless or useless. It's not ever going to do anything. And now we're kind of in a like big explosion of possibilities for AI. We see the same thing for infrastructure. We were on-prem, like every company had a data center for a long time, and being able to understand how to administer that data center was a really valuable skill. And then there was the pendulum swinged. Now everybody's on the cloud. And now I think what we're seeing is the pendulum's just swinging back. And I think it really depends. Some companies have done really well in the cloud, and they're going to continue doing well in the cloud. Some companies are discovering that they can do better when they're on-prem or hybrid. And I think it really comes down to like what sort of skills do you have? What sort of things do you want to prioritize? How does this impact your bottom line and your business? And um, yeah.
Okay, okay, that's fair. And maybe like I love like ending with a bit of like predictions. Like it can be around any topic, but let's say that you are talking a couple of years, like what's going to be different. And you can talk about scaling, you can talk about carpenter, new technologies, the Kubernetes itself, like the SIG.
Mhm.
Where are we going like in a high level overview, like as a whole?
This is a really interesting. I spend a lot of time thinking about this. I think what we've built with Kubernetes is kind of like the low level layer. So we have all of the pieces there to really uh, run and deploy an application in any sort of way that you want or can imagine. What I think is missing is the uh, sort of the abstraction on top of that.
Mhm.
So every company, Yelp had this with pasta, Airbnb had their own internal thing. Every company is building their own abstraction layer to make it easier to manage.
Yeah.
And so I think about like, uh, I have an analogy where I compare this to programming languages. Like we had assembly and we had C and we had C++. And I think we're kind of in the like Kubernetes is like C++. But then we
Python.
built Python or we
Yeah.
built Rust or we built Go um, on top of all of this stuff. And so I'm really like where I want to be is like what's the Rust or what's the Golang that we're going to develop for distributed systems? I think that's a really fascinating question that um,
Do
we
you
don't
have
really
any?
understand.
Do you have anyone that you see that is like an interesting, like like contender right now, like for the new Python, new Guido?
I think there's a couple different really interesting directions. I actually gave a talk at KubeCon last year
Mhm,
around kind of multi-tier programming,
mhm.
where the idea is you know, let's take your monolithic application and have automation that underneath the hood deploys it in a distributed fashion. I think that's maybe one direction that we can go. And there's a bunch of like toy projects out there right now, but I've not seen anybody like be successful at making a production grade. Google Service Weaver was an example here, but that project was actually deprecated because it was really hard to do. Um,
Right,
and this, I think, is maybe an area where AI might be able to come in and help as well. Um, Maybe
okay.
it's able to understand like how your program is structured and figure out like which pieces can we split off and deploy elsewhere and which pieces need to all be co-located or something along those lines.
Yeah, interesting. I think programming language like Python as example. Even me as like a simple developer, I can understand Python. I can like benefit from it. When it comes to something bigger, as you describe, it's more on like how can I take the organizational complexity and somehow create something that is like one size fits all for a lot of like different companies, right? Which like
Exactly.
Yelp and Airbnb are quite different. Even there are then like currently Kubernetes is that like C++. So no, it's interesting take. Like I really wonder as well, like where is the industry going to go?
Yep.
Okay, David, anything else that you want to say to our listeners?
I don't think so. I guess maybe I'll just close by like, I really love the title of your podcast of like Kubernetes for humans. Like all of the tech that we're building, like all of the auto scaling or the, service mesh or whatever, like that's there in support of humans. And so I really love the sort of message that sends of like, we're trying to build stuff to make, humans better and to make humanity better. And so really appreciate that message around your podcast and hope that that's something that we can all kind of continue.
I do hope that as well. Thanks a lot, David.
Yes, thank you so much for having me on the show.
Pleasure having you.